Welcome to today's class. We are going to continue from where we stopped. Last time we discussed about the choices of wiring system, the factors that affect choice of wiring system. Today we are going to proceed further and talk about the tests that are performed on complete installations. Today are quite a few number. I don't know why. But nevertheless, we're going to continue. We will have this session recorded, and if in case you have a question or query as we proceed, you can note it down on the public chat. I'll be able to respond to you in due course as we proceed. So once again, welcome. So I'm saying that we're still under topic 3, sorry. We're discussing the solar system accessories, and we are doing a subtopic on tests that are performed on complete installations. So this comes after you have done your installation, and then now before you the tests are usually divided, that you can perform the test before you energize your installation or after. So this is what we mean by energizing is that before the test can be performed before you connect to the national grid. That is before, for our case here in Kenya, before the KPLC connects you to the power, or after you have been connected. There are some tests and inspections that are done. For the inspection, definitely this will be before, so that the authority is able to inspect your installation and certify that it's up to standard, so that when they connect you to the grid, it does not become a problem. It does not resort to fire and other catastrophic occurrences. So when you talk about test and inspection, we can it comprises. We're going to discuss three major categories. It will be we'll categorize them into three. One, the initial verification. So this is usually the first step when you're doing tests and the inspection. So you verify. Number two is will be the periodic inspection and testing. So this is regular. And then the last one is the certification and reporting. So this is after everything has been done. You are certified, and it's reported to the authority whether you have complied to the standards, and then the necessary steps are taken. If you are certified that you have complied, then you can be connected. If there are some things that need to be addressed, then the same is addressed at this stage of certification and reporting. I always advise students to have a notebook so that you continue to take notes. So let us start with the inspection and testing, the whole integrated procedure. Inspection and testing as an integrated procedure. The activities of carrying out visual inspection and then carrying out testing should be considered as complementary procedures, and this should not be considered to be separate function carried out by separate individuals or organization. And this is particularly true of the inspection confirmation part of the inspection and testing. So that I can illustrate this point, in general, there would be a little point in carrying out a continuity test on a cable if it had not, if it had been found that some of its connection terminals were loose, and the defect will need to be remedied before the tests are conducted. Yeah, that's a little bit of ascertaining. Another aspect to consider are the stages of inspection and stages of testing for larger installations. That is where you have like an apartment or a whole a big building, not a small domestic installation. So that's what you're saying, that the stages of testing for larger installations. Excuse me. For many such installation, the inspection is formally carried out at the end of the construction element of the electrical installation process, often as a separate test. The electrician or the engineer will undertake this task, but however, the amount of visual inspection undertaken during the electrical construction stage is often very significant because most electricians check visual elements like the polarity, the tightness of the connections. This is to ensure that they are not loose. And also, indeed, the many of the items are required under the visual inspection element of inspection and the testing. We're going to go through these elements, the individual or the checklist of the visual inspection. These visual checks are done as a matter of course, but often the test engineer or the electrician who is partaking this visual test completes the visual inspection separately and without consultation with the installation electrician. It is suggested that this inspection, the first step of the inspection and the testing process, is more efficient and generally better if it's carried out inherently by the installers. And there are exceptions when definitely this cannot be achieved. And a particular example is where the semi-skilled laborer is being utilized for installation. So when you have especially when you're doing, we talked about the other time, the types of installation, the wiring system, when I talked about the, the, the use of cables. So when this is being done by a semi-skilled laborer, definitely that person is not able to conduct this visual or the whole test and inspection. So this is where we are saying these are the exceptions. But as the suggestion goes, it is the testing process is more efficient and should be carried out inherently by the people who have done the installation. This is important because it ensures there is a continued smooth flow of the installation process. It is suggested that for large organizations that a system be created that allows the installer to confirm facts about the visual inspection. And you're going to look at a table that suggests the items that can and should be carried out during this electrical construction procedure. So without wasting much time, let us go straight to the first element of test and inspection, and that is the visual inspection. The visual inspection part is the initial verification step in the process of assessing the installation prior to testing. We have the IEE regulations that usually specifies the purpose of the visual inspection, and they can be summarized as follows. So we have those IEE regulations. That is, we said IEE means the Institution of Electrical Engineers, and they have summarized the purpose of this visual inspection. And this one is usually a common question, the NEC like testing. We are told to describe the purpose of visual inspection as per the IEE standards, and is that during visual inspection, the equipment should comply with the product standard. Number one, equipment complies with a product standard. Equipment complies with product standard. Number two is that the equipment should be correctly selected and erected. The equipment should be correctly selected and erected. Number three, equipment is not damaged. That's another purpose of visual inspection. I've said number one, visual inspection ensures that the equipment that have been used, they comply with the product standard. Number two is that equipment is correctly selected and erected. And number three, equipment is not done. So those are the three major purposes of visual inspection under tests and inspection as per the IEE regulations and standard. We're going to summarize the requirements of for the inspection part of the initial verification, and to be consistent with this chapter, the protective measures like the pressing out of breach and similar have been we're going to remove them from this table that you're going to discuss. That is the checklist on the visual especially considered at the installation stage. And that table, the checklist table for the inspection, should have an column whereby as you check your installation, you tick as appropriate. This column should indicate the facts that should be automatically inspected by the installer. For example, how an installer can install a cable, and if does not know the designer's specified cable size, how to go about that. As a further example, the installer should not be terminating cables if he does not know the IEE standards aspects of relating to the tightness of the connection. That's why we say the installer, the electrician installer or the engineer should be the one to conduct these tests and inspection, because they'll be able to ascertain, like this one that you're saying, like the tightness of the connections, and that installer should be inspecting that work. That column also should inherently be carried out by the installing operative and completed on the inspection checklist paperwork and passed to the test engineer if this is a separate individual, but which we discouraged. We said it is important that the installer is to remain also as the test engineer, unless he's a semi-skilled worker, is not an approved engineer. So in your notebook, I want you to note down that table. For the purpose of time, you're just going to put down the checklist, the visual inspection requirements. What if you happen to be employed by Kenya Power and Lighting Company, and you'll be tasked to be carrying out this visual inspection to installations before they are connected to the national grid? What are you going to be checking? So I want us to go through those tests, those inspections that you're going to go through. And when this becomes practical work, when you'll be doing this in your field, that is during probably your attachment or your internship, or if you'll be lucky to work with KPLC. These are the tests, the inspection that you'll be carrying out. So we are going to have the inspections. Yeah? So the first inspection under visual inspection requirement is the erection method. Which methods can have been used in this installation? And this one should be carried out at the installed stage. So the erection methods, and they should be able to conform to the IEE standards as we've stated above. Also, another item on the checklist on the visual inspection is the conductor terminations. We have talked about how to terminate conductors. For the September guys, we are able to carry out these terminations when we are doing the practicals in the workshop. So when you're carrying out a visual inspection, checklist number 2, it should be conductor terminations. How are the conductors terminated in this installation? That is something, and some of these things, they don't necessarily have to be it's a bare use of that general common sense of an engineer. You just check the conductors, how have they been terminated, do they pose any risk, and then you're able to to make a comment or tick as appropriate. Number three on the checklist is the identification. When you talk of identification, you can put a hyphen and say, here we are going to discuss, you're going to check on the colors, the labeling or the color of the cables, and also the labeling of these cables. To expand on that is that during installation, or generally in electrical engineering, cables, we have cables of different colors. If it's a single phase, most of the time we'll have three cables, the live, neutral, and the adding or the CPC cable. And we know the colors that they should be for each of the three cables. For the live, in Kenya, we use red. For the neutral, we use black. And for the other cable, we use the multicolored cable that is green and yellow. If it's a three-phase, we have three power cables, three live cables, and in installation, we also have a fourth cable that is the neutral, and also a fifth cable for the earthing or the CPC, a protective conductor. So for the three, in Kenya, most of the time we use blue. The three live wires we use blue, red, and yellow. And then for the neutral is black, and the CPC, just like in single phase, is green and yellow. So you identify those cables, identify if they have been the right color has been used, and also if we when you're doing the practicals, we saw how you can use the return wire, that is the black cable, as a switched live cable. So that is where the labeling comes in. We said you label it at both ends of that cable using a red masking tape to show that it's a neutral cable, but it's a switched live cable. So that is the labeling of the cables. Another thing that you check during visual inspection is the installation of the cables. This one marries with the other point, and this is to ensure that there is mechanical protection, that the mechanical protection to the cables. So this means that your cables have been well protected from mechanical or physical damage, and this is where the last class comes in when we are talking about the types, the wiring system, the choice of wiring system. So this one depends with where you're installing your cables. If you're going to use the metal conduits, that is in the choice of wiring system, the conduit type of wiring system, and you're using, maybe it's a heavy factory, your installation should be that of metal conduits, to ensure that this point of the mechanical protection of the cables is well accommodated. This is to ensure that the cables have been protected from physical or mechanical damage. The next checklist under the visual inspection is cable size as design specification. Cable size as design specification. So we know we use different sizes of cables as specified and IEE instructions and regulations for different types of installation system or different types of final circuits. And for those guys who were able to attend the practical sessions before the COVID, you saw how we'd do, like for lighting final circuits, we would use different sizes of cable, and also for lighting, we usually use around 1.5 millimeter squared cables. For the power circuits, for the domestic installation, we would use a different type, like around 2.5 and 3.5. Or when you are heavy circuits such as electrical, and so we would use cables from 4.0 to 6. So that is what we mean by cable size as design specification. So when you're carrying out this visual inspection, you should be able to ascertain that correct size of cables have been used. Because you see, if you have an installer use, let's say, maybe 1.5 for heavy power final circuit such as the cooker. So if you use a 1.5 cable for cooker circuits, that means that that installation generally is not safe. And when you have your loads connected, and you know a cooker is a resistive load, so when you have your cooker connected, there is that high chance that your that system, that whole installation system, will blow out because it will not be able to accommodate all that power flowing through it. So that's why we're saying cable size is a requirement, or is a factor to consider when doing visual inspection. And how can you do this? You just go with and these cables, you can just identify them with the time. You'll be able to identify them naturally. When you check 6.0 and maybe a 2.5 cable, you can tell the difference. And also 1.5, you can tell the difference. You don't necessarily actually have to carry out the measurement using maybe vernier calipers and so on. So that is the cable size as design specification. And this one is also carried out at the installation stage. The next thing that you check is the building's ceiling around cables and the trunking. So you check the trunking, how safe are they? Have they been done well? And also the ceiling of the building. Number next is the presence of means of earthing. You check if your installation have been earthed correctly, and this is to ensure, you know, what the other time with the September class we talked about the importance and the necessity of the earthing system. You check if the earthing system have been correctly earthed. This is to ensure the safety of the whole installation and the safety of others. You know, in electrical engineering, when you have a fault, sometimes you have seen faults being transferred through the KPLC wires from one building to the other. So the presence of means of earthing is an important factor to consider at the visual inspection stage. The next thing to consider is the presence of protective conductors, such as the CPCs and the bonding. Presence of the protective conductor, presence of protective conductors, the CPCs, and the bonding. This can be combined with the earlier point of the presence of means of earthing. The next thing is the means of isolation. You should be able to check if your system has correct means of isolation. That is, this is facilitates this. All these are protective measures, so that when you have a fault occurring in your system, this means of isolation will be able to rectify your. You'll be able to isolate if there is a fault, isolate the fault system with the other parts of the system. And this is achieved by use of the switches and maybe the MCBs and the RCDs, the residual current devices. So means of isolation as an important as an aspect in the checklist of the visual inspection. The other thing to check are the warning notices. The warning notices, what do you mean by this? You have seen around, even where you are, if you're in a commercial building, you have seen that there are those notices that are usually labeled around. Like you see something noted, like in a lift, you see a notice saying high voltage, do not touch, do not operate if you're not a technician. Those are the notices that you're talking about. So the warning notices are a factor to consider under visual inspection. Another thing are the diagrams. This comes for in a factory setting and those sophisticated installation places, whereby you need diagrams to show how your installation have been done. Because when you have a heavy, like in the university, when you go to the control center where all the final circuits have drawn their power from, you need to have that diagram so that you know this MCB controls where. This MCB controls room 203. This other one controls room 502. This other one controls the staff room, and so on and so forth. So those are the diagrams. The other thing to check are the equipment. You check that your equipments are up to standard. These are general checklist. Check that the equipments are up to standard. When you talk of equipments, these are things like the CCUs. You check that they are up to standard. The MCBs, the RCDs, the switches, the sockets, and so on. All of them, you check that they are up. Like when you talk about the MCBs, this means that MCBs, they are rated according to the amount of the current that they can be able to sustain. So if you're in your installation, you want to run a machine, a motor, heavy motor, and you have used an MCB rated 6 amperes, that one definitely won't work because you'll be overloading that MCB. And every time you start your load, that is for this case the motor, then your MCB definitely will trip down. So that is what we mean by the equipment. They are up to standard, and also ensure that they are correct. They are the correct type of equipment that are used there. If it is you want to use let's say a 4-way switch, where you have the 3-way, and you have the intermediary switch, and the switches that you're using there, they are not necessarily 3-way switches, then definitely those equipment, they're not up to standard. And that is what we mean by checking the equipment during its visual inspection, that they conform to the standards that are laid down. And with this one, the spot checks may be useful. You check them on the spot. The other thing to consider during visual inspection is the adequate access to switch gear. To check that your installation has that adequate access to switch gear. So this is also a protective measure. Your switch gear is adequately, it can be accessed adequately. The next thing to check is that this is what we have said, the current devices are correctly sized as specified. The RCDs, the MCBs, the fuses, all of them, that they are correctly sized as specified according to the type and the size of the load that you want to use. For the lighting, you can use even the lowest rated MCB, like the 6 and so on. But as the loads increase, definitely you need to use MCBs and RCDs that can accommodate those heavy loads. So that is what I mean. The overcurrent devices are correctly sized. The same case applies to the fuses. You have fuses that measured that are used to protect against different sizes of currents. Like you have at the intake point of domestic consumption, you have the cutout fuse. That cutout fuse is usually rated at around a minimum of around 80, let's say 80 amperes. So if you are sent to check to conduct a visual inspection, and you check the cutout fuse is below something like 80, or according to the standard that have been set out by the KPLC, then you make a comment and you say that this one needs to be changed. So that is what we mean by overcurrent devices are correctly sized as specified. Another thing is the presence of the RCD protection where required. This one is not always a necessity, but where required, as where it's needed, the residual current device, where it's needed, then you might need to check its presence and ensure that it's correctly rated. And the last thing that you check under the visual inspection is the under voltage devices there where required. You check under voltage devices are present where required. And this also is also checked at the installation stage, and you need to confirm that as you proceed. So those are the major components of the checklist of a visual inspection. And That is how you go about visual inspection. Maybe some points to note is that it should be apparent that if an organization employs separate inspection and test engineers, much of the inspection work should be a conversion and completion paperwork exercise with the test engineer. And this exercise is better if the inspection paperwork originates with the designer and is passed on to the test engineer. And in this situation, it should not be the function of the test engineer to repeat the inspection of the items confirmed by the installers. And because this is not a requirement of the regulation of the IEE regulations. The next thing that we're going to talk about is the testing now. Remember, we're talking about tests and inspection. So we have done that first stage of the visual inspection. So the next thing is usually the testing. After you have inspected and you have corrected where necessary, then the next step is to do the testing. The testing, these ones are usually a number of them. There are different types of testing that can be carried out in an installation. And this one usually depend whether your installation is dead or live. And when we mean by dead is we don't necessarily mean the death of the death as you know it generally. When you talk about dead installation or a live installation, this is with respect to if it has been energized, if your installation have been connected to the power and there is flow of electricity in your installation, then that is a live installation. If there is no your installation, in your installation there is no flow of electricity, then that is a dead installation. That is what we mean by dead or live installation. So in this test, we have said there are a number of them that can be conducted on an installation, depending whether it's dead or live. So under dead installation, we have the continuity ring installation, and under that we have the insulation resistance. I repeat, in the dead test, and in a dead installation, we have the continuity installation plus the ring installation, the ring test, and also we have the insulation resistance test. Also under dead, this one is usually relative. You can conduct it whether when dead or alive, depending with exactly the type of instrument that you're using, is the polarity check. The polarity check test. And we are able to do that during our workshop practice sessions with a number of you, especially the certificate class. So when you talk about the polarity check, this is to ascertain if the polarities of your installation have been correctly used. And also under live, so those are the tests that are carried out under dead installations. We have said the continuity, the ring test, the installation resistance, and the polarity test. For the live installations, we have said, so the first one under live is the polarity. That one we have said can vary. It can either be under dead or live installation. And the other one is the earth loop impedance test, or the ELI, earth loop impedance test. Another type of test that is conducted in live installation is the fault current measurement. The fault current measurement, or the FCM. And the last one is the RCD test. The RCD test. So those are the tests that you can carry out on live installations. So we're going to discuss them in details one by one, and we'll be able to check the IEE regulations that partakes each one of them and what is to be done, how do you carry out these tests, and so on. So those are our tests and inspections. I don't know if there is any question after that point. Any question? So any question, Grace, Karanja, and the rest? I can see there is somebody here. Okay, Francis saying there is no question. So if there is no question, that will be our class for today. So from on Friday next class, we'll start with the continuity testing. Continuity testing, that will be our first. We are going to discuss that in detail. We are going to take the different methods that you can use for this continuity testing. Meanwhile, you can read ahead. For those guys, for you next students, we have because of this COVID situation, most of you, I don't know, you're not taking the learning seriously, but you should know wherever we stopped before the COVID, that is why you pick up, because these classes, they might not necessarily be repeated, and those guys who are failing to attend, it will be up to them. And we said that if you don't attend classes, then most likely you won't pass. So ensure that you do your best. And because of this situation that we are experiencing right now, it gives you time. It said that you should take advantage of every situation. So right now you have ample time for you to revise and to ensure that you get those high grades and you're able to proceed to module 2. And that can only be achieved if you take your studies seriously. So I'd encourage you. You have quite a big class, but the attendance have been a little bit poor, because especially for the live sessions. Yes, people attend usually access the notes and the live classes later on, the recorded versions, but they usually do not necessarily attend the live classes, and not everything that we say in live sessions will be uploaded on the notes. Somebody is asking for the notes. This is Francis. The notes I'll be uploading, and I've already uploaded a number of topics, I think up to topic 4. So ensure that you check that. If you experience any trouble, I'll be able to assist you. So until next class, have a good day and keep safe.
You are currently the only person in this conference.